Yes, and hopefully everything won't blow up. You guys don't understand how much this means to me, like physically. Yes! Hey people, Lion here. Last episode, I fried my PCB. This time, things went better. The new parts are here, I did some CAD work, and I also wired everything up without any accidents. And for the first time, I finally got to play the damn game. This is episode 4. This is the new joystick that I have bought. I have installed it in the frame already, as you can see here. This is the new PCB that I bought. Looks very nice. Yep. So what I'm going to do first is I'm going to plug in the joystick into the PCB first. Whoop. Boom. Okay, nice. Done. Next, I have this. These are my buttons, right? And for now, I just put in the wires for one button here. As you can see. Delightful. And this here is the power cable and the signal cable for the PCB for it to connect to my computer. Plug this in. Delightful. And now we're gonna test if all the directions work or not. Plug it in. What you want to do if you're setting up a new fight stick is set up USB game controllers. Let's just search it up. Set up USB game controllers. Boom, like this. And as you can see here, it sees the PCB. So here it is, generic USB joystick. And I can go to, no, I gotta go to properties. Yes, and now I can see the test. Now let's first test the buttons. Yes, it lights up. That means it works. Awesome. And now time to test the joystick. Oh, yes, it works flawlessly. Every direction is recognized. Boop, 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 boop. Success. Great success. So my PCB and joystick works fine. That's awesome. However, do you guys remember the hole I cut into my PCB in the last episode? Yeah, that came back to bite me in the ass this episode. Because now the hole is way too big for my new cable and it's like all loose and stuff. So I'm gonna have to design a new port cap in CAD to cover up that hole. Which leads us to our next segment, designing a port cap in CAD. The first step of designing anything in CAD or anything in general is you need to know the specifications of the thing you're going to design. In my case, I need to know the dimensions of this bit here and the dimensions of this bit here, this hole here, to know exactly how big I need my design to be. You know, I'm thinking about making a hole patch or hole cover, and like it has another hole in the middle for this to go through. Yeah, so let's measure it. I have a ruler here. Normally, someone would use a caliper or something more professional, more precise, but all we have today is a ruler, so we're going to use that. And after we have our measurements, I'll make a rough sketch of the thing I'm going to design in CAD. I am now going to be designing my part on a piece of paper first, so we know what we're working with. So we know that the hole needs to be square, right? The hole needs to be squared. And this hole is 0.9 centimeters by 0.9 centimeters. Now we know that the hole is 1.5 centimeters, right? It's 1.5 centimeters, like this. 1.5 centimeters long. And 1.3 centimeters tall. Like this. Hopefully you guys can see my drawing right now. This is the front view, right? Very basic shapes because I can't draw to save my life. Anyway, let's draw the side view now. Now we know that this bit here is 0.9 centimeters thick, right? 0.9 centimeters thick. So I want to overshoot that a bit and let's do 1.3 should be good. 1.3 centimeters, yeah. So our build will look something like this. Let me draw it. Boop, 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 boop. here, right? And let's do a hole in the front here. And it would, this side would be 1. Let's do 1.3 centimeters long, right? It would be this deep, like this here. Yeah. And we know the measurement of the hole in the middle. I drew it here, see? And all we have to do now is just render it, draw it up in the CAD software, which I don't have that much experience with, but we will try. It shouldn't be that hard, right? Also, for those who are unaware, CAD software is not like normal 3D design softwares like Blender. Because Blender makes shapes using geometry, right? However, CAD software is a lot more precise than that. It uses math to draw shapes in 3D space. And it's what people use to make parts that will actually be used in real life. And Blender is more for, it can be used as a CAD Blender, you can design stuff to be printed in real life with Blender. But the more specialized software are CAD software. And the one that I'm going to be using is Onshape because I heard that it's pretty good. And the most important part about it is that it's free and I am a broke student. I would use like something licensed because universities probably provide that for you. However, I am not a real engineer. I don't have access to those, licensed CAD software. So I'm going to have to make do with free software instead. Yeah. I'll see you guys soon. Hooray! I finished my first shape, I guess, my first CAD software build, whatever it is. I'm gonna try printing it. Let's see how it goes. So what I have here is my 3D model in this file here. It's in this micro SD card. It's pretty dark over here. Sorry for the bad lighting. And this is my Ender 3 V2 that I have preheated. So it's ready to print by the time I plug this inside. So let's go. The thing with my 3D printer is it's kind of unreliable. I have to like stare at it for the first few layers to make sure, the bed leveling is alright and everything. So yeah, please bear with me, guys. It's printing very nicely. Just did some Z offset adjustments and yeah, it is now very level and printing very nicely. I'm just gonna let that run for a while. Yeah. And then after we can come back and check if it actually fits with our designed part or not. If it actually fits the box, the enclosure, I mean. Yeah. Love you guys. So I just finished printing this. The machine just finished printing my piece here, as you can see. And there's a critical design flaw I've got to, consider. For this to work, the cable here, this end needs to be able to go through the hole here, right? However, the hole was designed to just fit this part here, but this part is thicker than this part. So when I try to shove it in here, it doesn't work, it doesn't fit. Also, I tried test fitting this bit with a cable port with this bit, and it does not fit at all. It can fit this side, but that's not the side I wanted to, so it can't fit like this. And yeah, this means that my measurements are wrong. It can't fit like this. Oh wait, you guys can't see it. It can't fit like this. See, it doesn't go in. It doesn't go in. This means that my measurements are wrong. And maybe I just have to scale this down a bit, but I think I have to redesign the whole thing. I think we have to redesign the whole thing for this this end to be able to go through as well as hold this part tightly. Yeah. I'll come back to you guys later. Hey people, so what I have designed here is the cable port, the new cable port. Let me focus in on that real quick. See here, I have designed this new cable port because my first iterations did not fit the hole. So what I decided on was, you know what, forget about fitting the hole, I just cover the outside instead. Yeah, so I just made it cover the outside. The cable is held in pretty snugly. So that's one objective done. And yeah, look, it holds the thing in tightly, everything fits very good. And now we can finally work on mounting the PCB inside the enclosure. To mount the PCB, I printed out some PCB mounts here.
I got this from Thingiverse. I'll put a link or maybe a picture on here. And I'm planning on, you know, using a piece of foam to put it under the PCB, something like this. And then I'll put the mount on, and then I can screw the mount onto the foam. Yeah, that's my plan. Because I don't want to drill directly into the floor of the enclosure itself. Because I don't think that's a good idea. You know, what if the screw turns out to be too long or whatever, right? And the reason I had to use a PCB mount at all, right? The reason I had to use these was because the holes on the PCB, the screw holes on the PCB are way too small. I don't have any screws that small. However, these PCB mounts have bigger screw holes. See here, I have hot glued the mounts to the PCB. And then what I'm going to do afterwards is I'm going to glue these pieces of foam into the enclosure itself. And then I'll be able to screw the PCB mount onto the foam like as shown here. That is the plan. As you can see, this is how I will mount my PCB. That rhymed. Okay, that's weird, but that rhymed. Anyway, I have pieces of foam on each of the PCB mounts. I'll glue the piece of foam to the enclosure, like this. And then I'll be able to use a lighter, you know, on a tiny screw here, which will melt through the foam and then be able to screw in tightly and secure my PCB without having for me to know A, buy extremely tiny screws, or B, glue the PCB directly to the enclosure. Yes. It is now tightly secured. Would you look at that? Very secure PCB complete. Okay, I finished mounting the PCB. Now to the scary part, which is wiring the buttons to the PCB itself. I'm scared of this part because there's a chance, could be a small chance or a big chance, of me messing it up again and, you know, frying another PCB. Yeah. What I have with me here is my box of wires that I will use to wire my buttons. And once I wire my buttons, everything should be done, and we can finally play on this stupid thing. So everything has been wired, and now I'm going to plug everything in. And hopefully everything won't blow up. And if it does blow up, it'll make for great content. So yeah, let's go for it. Please don't blow up. Machine spirit be with me. So this is my fully wired fight stick. First I'm going to check if all my inputs work, so let's do that. So USB game controllers. Set up USB game controllers, boom. Generic USB joystick, let's go to properties. Let's check if all my buttons work. Yeah, yes, 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 yes. I may have wired them backwards, but that doesn't really matter because I can just remap them in the game I want to play. So that's what we're gonna do now. All my inputs work. All my buttons work. Hell yes. All I have to do now is just seal this up, you know, put all the panels and screw everything down, and then we'll be ready to play Tekken 8. Let's play Tekken 8, let's fucking go! Right now, I have brought my screws over, and I'm gonna screw in both top plates, so it's ready to play. I think I just dropped the screw, whatever. Okay, let's go! Ooh, I'm shaking with excitement, guys. You don't understand how long I've been waiting for this. You guys don't understand how much this means to me, like physically, not physically, mentally. Put this on, screw the ball top on. And we're good. Before I show you the gameplay, I just want to say that I am horrible at Tekken. Doesn't matter what I use. Doesn't matter if I'm playing on a keyboard or a fight stick. I am horrible at this game. but I like playing it. So yeah, you have been warned. You are about to see the world's worst Tekken gameplay. With that being said, let's see the gaming.
Yes! Yes! Bang! Yes! 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 At the end of every stream, block.
So yeah, the fight stick works. It actually works. And I'm really proud of it, and I'm really proud of how it turned out, right? And I learned a lot of things along the way, like what is a PCB? How do wires work? What does grounded mean? And it's a really big step for me, personally, because I started this project initially just to show myself and everyone that I can stick to something and finish it, that I won't half-ass my life or anything else anymore. And yeah, it is a really fun project too, and I really enjoyed it. I enjoyed learning new things. I enjoyed learning CAD. I enjoyed, learning to edit better, etc., stuff like that. And if you guys enjoyed watching me suffer, please like and subscribe, because I will definitely be doing more weird stuff like this in the future. Thank you so much for watching, and thank you so much for supporting me. Thank you so much. I will see you guys next time.